Hello, this is Ms. Andersen. Today we're going to look at quadratic functions, and by the end of this video you should be able to write the equation of quadratic functions in vertex form and graph quadratic functions given to you in vertex form. Okay, so quadratic functions are everywhere. You can see them in bridges, in amusement park rides, in vertical motion, like when kicking a football, etc., in architecture. And these are some uses of them. We're going to get right into this though. So given a graph, you should be able to write the equation of the function. So remember, remember this form. So remember, h is going to move our function right or left, depending whether it's positive or negative, and k is going to move our function up and down. So we can start with this function. We'll have y equals, or f of x equals, and notice originally y equals x squared, the vertex is at 0, 0. Our vertex moved 1, 2 to the right, so we're going to have x minus 2 squared because it's a parabola, and it also moved 1 up. Okay, and that's it. We know a is positive because the parabola is opening upwards. If you think about y equals x squared, I'm just going to sketch it really quick. 2, 2, 3, 4. Okay. So y equals x squared. Notice it has the points 0, 0, 1, 1, because 1 squared is 1, and 2, 4. And you can see those same points mimicked here. So the transformed function, the vertex just moved 2 to the right, 1 up, but it hasn't stretched or shrunk. A hasn't changed at all. So from there, if we go up 1 over 1, we've got our point. And if we go over 2 and up 4 from the vertex, so over 2, up 4, we've got our second point. So we know that a hasn't changed. It's still 1 in that example. However, we'll look at when it does change in this example. So here we've got y equals, we know it's going to be a quadratic function because we've got a parabola. It's upside down, it's flipped over, so we know a is going to be negative. We can see that our vertex moved 1, 2, 3 to the right, to the left. So we've got plus 3. X plus 3 moves it to the left, and then we've got 1, 2, 3, 4 for our k. So our function moved up 4 as well. So our vertex moved 3 to the left, 4 up. And notice here, instead of going 1 down, 1 over, our function is actually going 1 over 2 down, making our a negative 2. So normally if you think about y equals x squared, we've got 1, 1, we've got 2, 2 squared is 4. It's like this, right? So this transformation, we can tell that a has been multiplied by 2 because it's got a vertical stretch. It's skinnier, and instead of going 1 over 1 up, or in this case 1 over 1 down, we're actually going 1 over 2 down to get to the first point. And it should be 8 down for the second point. So let's see, 2 over 1, 2, 3, 4, 5, 6, 7, 8. So instead of 2 over 4 down, we've got 2 over 8 down. So we can see that a is negative because it's been flipped upside down, and 2 because our y value is increasing, is multiplied by 2 each time. Okay, so not only should you be able to look at a graph and write the function, you should also be able to take a function given to you in vertex form, draw the graph, and be able to give some information about it. So we know our vertex is going to move 3 to the right and 1, 2, 3, 4, 5 down. with this function because x minus 3 moves it to the right, negative 5 with k is going to move our function down. We know our function is going to open upwards because a is positive, and a is 1/2. So instead of going 1 over 1 up, like we normally would for a parabola, we're going to go 1 over a half up. 1 over and a half up. Okay, and then normally we would go 2 over, and 2 squared is 4, so we'd have the 0.24, but instead we're going to go 2 over and half of that, which is 2. It's normally 2, 4, so instead we're going to have 2, 2. So 2 over, 2 up. Next would be 3, 9, and half of 9 is 4.5, so we'll go 3 over, 1, 2, 3, 4.5. And so on. And so there's our parabola. So what's happened there is our function's gotten wider than y equals x squared, and it's gone through a vertical compression. So the vertex of our function, it's moved right 3 and down 5. So 3, negative 5. The axis of symmetry is always going through the vertex. It's always going to be a vertical line, so we write it in the form x equals positive 3. Whatever our x value of our vertex is, it's going to be the same as the axis of symmetry. So this vertical line is x equals 3, so our axis of symmetry is x equals 3. The variable a, determines the direction of opening. So in other words, is our parabola opening upwards or downwards? In this case, it's opening up. And the width, we just talked about that a gave us a vertical compression. So it's gotten wider than y equals x squared. Okay, and this one here, this +1 for h tells us our vertex moved 1 to the left, and +6 tells us it moved up 6. So 1, 2, 3, 4, 5, 6. Okay, so our vertex is now at -1, 6. A is negative, so we know our function is going to open downwards. What else do we know? A is -2. So instead of going, 1 over, 1 down, 2 over, 4 down, and so on, we're going to go twice that. So instead of going 1 over 1 down, we're going to go 1 over 2 down. And instead of going 2 over 4 down, we're going to go 2 over 8 down. Okay, so we've got this. And we could go 3 over 18 down if it were to fit, but anyhow, these keep on going forever. Okay, so axis of symmetry, same as the x value of our vertex. So x equals -1, it's this vertical line. Domain of any parabola is all real numbers. Range, whatever our vertex is, and thinking about a is going to help us find the range of our parabola. So we know that y, the greatest that y can ever be is 6, right? Never goes above this. So y is less than or equal to 6, or you can write that in interval notation from -infinity to 6. And that includes 6. 6 is included in that. So we can tell that from our graph, even if we didn't graph it, even if we're just looking at this function, we can tell, okay, our vertex is going to have a y value of 6, and we know our parabola opens downwards, so y is going to be less than or equal to 6. If a was positive, y would be greater than or equal to 6, because it would open upwards. Interval of increase, so this is a new term. Basically increase, if you can think about a graph with a positive line. So if you look at something from left to right and the function is increasing, it's going in a positive direction. That would be the interval of increase, always from left to right. So, and we always give it as x values. So when x is going from negative infinity to -1, our function is increasing. We could also write that this way, from negative infinity to -1. And we don't need to include -1. And then it's decreasing from -1 when x equals -1, all the way to when x equals infinity. It's going in this direction, left to right. So x goes from -1, x is -1 here, all the way to when x is infinity, our function is decreasing. So x is greater than -1, or from -1 to infinity. And that should be it. Yep, thanks.